Okay, Dan, welcome. I will be going through this example, which is basically a Revolve example. Um, just a few things that you have to note when you're working with Revolves. To work with Revolves, you don't have to draw the whole section. In this case, we can see there's a section on AA, which will give you this view, the section view AA. So this cross hatching, there is actual material that you will see, right? So what that means is that that is the only thing or the only part of the sketch that you would draw. You don't draw the sketch exactly as it is. You just draw the cross hatch section, right? So that's the only thing that you will draw. So when you revolve, it will automatically pick up that that's an outer edge, and then it will complete this line as well, or have this views as well. Okay, so that's very important. So one thing about this specific sketch again is we are looking at working with symmetry, and I will handle it as such. So I will only draw one half of it. So when you work with revolves, you only draw one half of it. And in this case, I already see that for me to make my life very easy, I'm gonna place my center of uh, my worker ordinate system or my sketch origin. I'm gonna place it right there, that's all, in the middle. Okay? So that's where I'm gonna place it, and then I'm just gonna draw half of this. That's my strategy. I'm just gonna draw half of this. So I'm gonna work from here, there. Just draw half of this. Only the section that has been hatched, which is now these type, I think it's type B lines that will show that's being used for hatching, and that indicates material. That indicates no material because there's no hatching there, so that's a void. So of course you just draw that, but you just draw half of it because this thing is symmetric. Here we can see again type G line showing that it's a geometric thing, and then you can just draw half of it and work from there. Okay, so I'm just gonna undo, and then save it like this. So again, strategy: draw half of it, mirror it. This is symmetric, so I will revolve it symmetric as well. Boom. Now I can go back to NX. Just go back to this, create a new part. Say revolve. Of course, the specific sketch. Don't get me wrong. This specific sketch can be done by using extrudes as well. But let me tell you this, it won't be smart to do that. Don't use, when something is round, use your, because you can create a solid disk, and then you can cut out some of these sections. You can put in a cut extrude here, then you have to just manage the begin and end conditions to get this section here. Then you need to go and put drafts on it as well, so that you can have the specific draft angles, or you can put in a chamfer there. But that's unnecessary. It's a lot of work. And then you can maybe just do one half here and then mirror it. Yeah, but it's a lot of work where you can just draw this figure as it is, and then of course use two features to create this part easily. Okay, because you want your design tree to be as elegant and as clean, or in this case the part navigator to be as elegant and as clean as possible. So I'm just going to create a sketch, gonna have a look at my orientation. So if you look at this will be your front view typically, right? And that will be your right view. Come on, circle. That will be your right view. So it means when I draw the sketch, again, that's the front view, that will be the right view as seen from this side. So I'm just going to draw this top half of the right view, right? Because that's where all my detail is. If I draw this circle here in the front view, it means that I will have to make use of extrudes to do this part. But if I draw this side, can make use of the revolves because I have the profile. So a revolve is just a profile that's being rotated around an axis. So that's the axis, right? That I'm going to be rotating. Okay. So in this case, I make sure that I select the right plane, or I can go through the standard way of doing it, right plane, and there it is. So this will be my axis of rotation. So I'm going to draw a profile line top here. And again, you don't need center lines in NX. You can just make use of these as well. So I'm just going to draw a rough sketch. I need to see what it looks like. Okay. Okay. What I would suggest is not to draw it maybe section by section and putting in a dimension and stuff. Yeah, but I'm just gonna define my stuff as per usual. I have a value of A. Just say I have a value of A of 122 and a value of B of 843, and then again my material is PVC. Okay, so I have my values. I'm gonna make use of expressions again before I start, and both of them are 122, and then the next one is B, that is 843. Okay, so both are lengths according to the sketch. So in this case, I have a look. I see my biggest dimension is B. So B is defined. There's B is defined from that point to that point. I'm only drawing half. So it means if I put in a dimension, since I'm drawing half of it, I just need to do that. And then I can put in a formula, B divided by 2. So you can do math inside of NX. And again, by placing that dimension first, it scales my drawing so that it's according to my first dimension. Let me just fix this again here. Point on curve constraint. So I know that's fine. Then I know that that point and that is also in the same line. Okay, just fix that. I know that my length is A. So again, from there to there, A divided by 2. So smart rapid dimension from there, that start point, to zoom in to that point. So I can drag my stuff. If the method is inferred, you can drag it until you get it as it is defined. In this case, it's just a normal horizontal alignment. So I can say this is A divided by 2. That will give me that. So now I know I change A, it will change there. It's fine. Next thing would be to put in this angle. What's important here is to check how it's noted. That's a horizontal line. So I need to make sure that I also do it. You can do a few things to do that. You can actually reference it from the center line as well. It doesn't matter. You can reference it from here. Okay, let's do a proper selection. Sketch origin to there. You can reference it from there and then say that, oh no, this is what's the English word for this now? But this angle and that angle is the same. In any case, so you can put something like that. But I have a rule. I like defining the angles as it is given. So this means that I need to put in some reference geometry to make sure that I define the angle as it's given. Just going to put in a line here. Okay, this is my reference. I can do with it as I please. I'm just going to make it 30. I don't want this to be part of the auto dimensions. So I'm just going to make this reference, right? So now I have that reference. Now I can define between that and that as a reference. And I can make it, what's the value there? Just see 15 degrees. Now I can specify it as it is, right? Again, that's 15. So you can also put in that same dimension, something in that line. So it's the same thing, right? So you can place it like that, but you can see it's over constrained. Doesn't matter. Again, that that's not actually necessary within NX because you can do this. Mathematics will explain why these two angles are the same. I'm Afrikaans, I don't know all of the terminologies and stuff, but yeah, in any case. So let's go. Let's see. Okay, so now we are done with this. So there's a 200 here. Again, what I want to do, I like to define the dimensions as it's given. I know it's a 200, so I can just type in 100. But because I like it, now if the 200 change, I know exactly, oh, that's the 200 that they're referring to. If it needs to be 300, okay? That's why I'd rather go through the whole exercise of doing maths, even though it's not necessary. Okay, so now I have done with this sketch. I got all of the information. Oh, there's another thing. This one here, 108. Then again, same principle. Divide by 2. Okay, so that's, now I know. Okay, so go to the sketch. Boom, 60, 105, 45, 20. Okay, let's see. So we have a 20 here. So I'm gonna just select that whole line. It's 20. And then from here to that specific line, wait until it turns red. 105. What happened? Okay. Then there's a 30 and a 45. So from that line to that, it's a 30. Then this whole line here, so 45. And then I think this and this, I think it's a 105. I'm not sure. Is it? Oh, yeah, it's a 105. And then, of course, we have another 60. So just drag this aside. It's fine. That's easy peasy. 60 divided by 2. Okay, so now I can see that my sketch is fully constrained by me placing a dimension here on this on the center line. If I didn't place it, it would say that the sketch there's one auto dimension missing, right? So as a rule for myself, I like to have everything defined and saying that the sketch is fully constrained without any auto dimensions. And now I know that that's fine. So I just need to use the mirror curve, all connected curves. Oh, no, doesn't want to do that. See, that line is causing me some trouble there. So I can mirror. Instead of that, let me use single curve selection. It takes a bit longer to select it, or you can make a box selection or anything in that line. For me, it doesn't matter. Center line again, you can select a shaft. Okay. Let's just make sure that we have a close profile to be extra certain that we're not going to sit with something that's hollow. And then I want to change this mirror. I want to edit it. So I want to include the line that I just drew in. So I just select the right click on it and then you can edit. So go towards those symbol for the mirror. You see there's a mirror constraint. Right click on it and then you can edit here or you can edit here. Doesn't matter. Then I want to just add this curve here as well so that I stick to having a fully closed profile before I do the revolve. Right, this will help you when you work with other CAD packages. Some CAD packages you don't need to draw in certain lines, but yeah, depends on what you, yeah, if you have basic principles that you stick to when you model, you will always get the right answer. Okay, so that's the thing. So axis of rotation, you can specify this line to rotate around, but that's dangerous because if that line isn't there anymore, then the revolve will be broken. So I specifically draw it in such a way so that I can make use of these the dating coordinate system here, or the axis of this specify. So you can just zoom in a bit, go towards that region. See, you'll get a lot of options. The 3 dots, then you right click and then you can select the axis from there. Okay, then you don't need to specify any midpoints whatsoever. Okay, so as soon as I'm done with that, I can update the mass, but I did something wrong. I need to assign a material. In this case, it will be, okay, let's see, update. See, it's 348. But in this case, I need to assign a material. This material was PVC. Boom. I apply. I update. And then that's my mass. Okay. So that's that. Revolve. See what's the next question. Following question is basically just to change the values of A to 134 and B to 3934, and then the material to steel. Right, so if you, it's two critical important things. You need to be able, or whenever a design engineer or whenever someone gives you something to draw or to model or design, you have to make sure that you specify the dimensions as it was given, because if you don't, the changes will be affected in places that it shouldn't be, right? Okay, so that's very important. So if the dimension is defined from that point to that point, you place it as such. You don't place it from here to here, otherwise the dimensions, the changes won't take place at the correct positions. Okay, that being said, you can change these things to, if you delete it or reattach it, you can change it to maybe show it as it is, but this isn't actually very necessary. It's just something extra that you can do if you want to. As I said, you don't need to. Okay, so that's our thing, because our mass, oops, what's going on here? Update the mass. Our mass still remain the same. Okay, so now we just need to edit our expressions. A is 134. Okay, and then B is what's B? 934. Okay, again, you can see, because this is defined as 20, that's defined as 20. There's the angle, there's the angle. So in effect, this length here is also defined, that space there. If I can just draw it in. So if you do this, just take that out again. Okay, so if you look in terms of this as a horizontal line, from there to there, that's a horizontal line, right? Let's do this. Just want those 2 points. Right. So if you look in terms of how these things work, you will always have one line that's not defined, because if you define it, you will have over constraints, right? So in this case, this line is defined as being 30, right? This line is also 30, okay? Because of symmetry, right? You mirrored. And then this line is equal to the sine. Okay, so we have this height here, right? And we have the angle. So you can use the tan function to calculate that, right? So the tan of this will give you this. So the program already does do that for you. So it means that this is also defined. The same on this side. It's mirrored, so it's also defined. Then the only thing that's not defined is this length from here to here, or in this case from here to here. So what basically happens when you change the value of A, that is because that's the only thing that's not defined. That's where the change will take place, right? So that's important when it comes to the mass of the part and so on and so on. So that's just something to note with why it is important to actually define the dimensions as it is given. And of course, for this question, that's all that's expected. Thank you for joining me, and enjoy the rest of your day.